My name is Dr. Amelia Fraser McKelvey. I'm an astrophysicist at the University of Western Australia and I study all things galaxies. We are doing a lot of different science here at Astro 3D.
I'm Anshu Gupta. I'm Astro 30 Fellow at Curtin University and I'm interested in anything to do with galaxy evolution. One takeaway, outflows are cool.
My name is Catherine Trott and I'm based at the Curtin University node, which is part of ICRA. And I partly lead the MWA Epoch of Reionization project, which means I'm interested in the first billion years of the universe when the very first stars were born. I was really interested in some of the results from the circumgalactic medium, so the Duvay survey. Some of the work that they're seeing with the CGM and the way that baryons flow into the CGM from a galaxy, I think is really, really exciting and something that's really new.
My name is Osan. I'm a first year PhD student at Macquarie University, Sydney. I'm studying basically galaxy evolution in galaxy clusters in dense environment. It's really a good opportunity for us to see what's going on outside of my field. And it's really good chance to see the bigger picture because we are studying universe, but we are studying with different aspects of it.
My name is Elaine Sadler. I'm based at the University of Sydney and CSIRO. I'm interested in many aspects of galaxy evolution, but I'm also the co-PI of the ASCAP Flash survey looking for neutral hydrogen in the distant universe. I think my takeaway would be that there's a lot of young people doing really interesting work, and it's fantastic to get a chance to meet them all in person.
I'm Adam. I'm a postdoc at the University of Western Australia and I understand why galaxies die. Make sure your talk is in the correct format for the presentation system. Science-wise, I haven't had enough time to digest it yet.
Hi, so my name is Temia Nanakara. I'm a postdoc at Swinburne University and I study the early universe with the new James Webb Space Telescope, trying to understand how the first galaxies form, evolve and die. Oh, there's been so many interesting things. For the moment, I think the most interesting thing I've seen is the new models that people are working on. And especially Adam's talk, I think. Can I be specific or not? Because when we do simulations of the universe, basically, we have so many knobs and things to turn around. And what he's showing in some level is that while there are a lot of things you can change, fundamentally most of these things are connected together.
So my name is Alma Mary Sebastian. I'm from Swinburne University of Technology, Hawthorne. I'm looking at the metal content of galaxy halos at very high redshift. I would like to mention the very first talk that we had here during a student workshop. It was pretty good that in explaining how to do your presentation, how to talk to different groups of people, how to tailor your speech based on the audience and things like that. So I think most of us were actually started to edit our slides once we listened to that talk. Yeah, it was the story I think it's the same story with everyone else. So yeah.
My name is Darren Croton. I'm at Swinburne University where I'm a professor and my interests are galaxy formation and large supercomputer simulations of how galaxies form and evolve. I love intracluster light. There's been 2 talks on it, or intra-halo or intra-group light, whatever you want to call it. I think it's the underdog. It's the thing that hasn't had much focus, but there's lots of interesting science there, and lots of the mass in a large galaxy system is hiding there. Hard to see, hard to measure, but I think it's pretty interesting.
My name is Andre Rista. I'm a PhD student at the International Centre for Radio Astronomy Research here in Perth, the UWA node, and I study galaxy evolution by looking at the kinematics of stars and gas. In particular, I'm interested in how these 2 components rotate in comparison to each other and what that can tell us about how galaxies evolve across cosmic time. I think for me, the most important takeaway is that Astro 3D is very diverse science-wise. I think my main takeaway was that there's a lot of ongoing and upcoming surveys such as MACPI, Duvay and MOVE, which are going to reach incredible resolutions. They're going to be addressing, and well, hopefully not just addressing, but answering some very interesting scientific questions in the near future.
So I'm Sonny Lee, I'm from Australian National University, and I'm working on the fundamental multidiscipline plane by Basic Matter. So you can meet a lot of people, a lot of senior professors. One advantage of that is that you can probably looking for your future like postdoc positions or something. And another thing is that normally when you read some paper and you have a lot of questions about this field, and when you send the emails to the authors, and it's basically very brief and quick response of that. But when you directly talk to them, you can ask all of the details of this work.
I'm Jack Lyne, at ICRA Curtin University, and I've been part of the Epoch of Reionization group for probably about 10 years now, but I work on the simulations of how the instrument sees the sky. We do way too much stuff in Astro 3D to keep up with. There's so much going on. It's great that there's central themes, but everyone's too productive.
My name is Professor Rich McDermott. I'm based at Macquarie University. My research area is on galaxy evolution, in particular stellar dynamics, stellar populations, and I also work in instrumentation. Takeaway for me is just the breadth and depth of research being done by the centre, in particular by its young people. I think a centre like this is such a great training ground for young researchers.